I can't get this.
Hi.
Whoa. Dr. Lane?
Are you having some problems trying to understand the error calculations?
Yes.
Here, let me show you how that's done. So we can see in column B that the target value is 40. In column C, we can see the subject scores. They scored a 45, a 40, a 35, one more 35, and then a 30. So the way to calculate constant error is to take the score that the subject achieved minus the target score. The next step in the formula is to sum the different scores that you see in column D, and that equals a negative 15. The next step in the formula is divide by n, and that's the number of trials, and we know in this example that the subject moved their arm 5 times. Negative 15 divided by 5 leaves you with a negative 3. So on average, the subject scored 3 units short of the target value of 40. Next, we're going to learn how to calculate variable error. With variable error, we're concerned about the variability of the subject's performance about their mean or their average performance. So the way we calculate this is we focus on column C, which is the subject's actual performance independent of what the target value was. So in this case, in column C, we see a 45, 40, 35, 35, and 30. We sum that value, which is 185, and we divide by n, which is 5 again. That leaves us the average score is 37. Now if we think back to constant error was a negative 3, which meant that on average they were 3 units short of the target. The target's 40 and they're 3 units short of the target, hence their average performance was a 37, which we just calculated here, 185 divided by n, which is 5, equals 37. So in column D, we put the subject's average score, which is 37, in all the cells, and we're now calculating the difference between the subject's actual score and the subject's average. So what we have here is subject's column C minus column D. So 45 minus 37 equals in column E 8. And the next one, C, which is 40, minus D, 37, leaves us a positive 3, etc. So the next step is then we square all of those difference values, which we can see in column F. So 8 times 8 equals 64, 3 times 3 equals 9, etc. Alright, and we sum those values, which sum to 130. Then we take the average, which is 130 divided by n, or 5. That leaves us 26, or the average of the squared values is 26. And then we take the square root of that value, the 26, take the square root, that leaves us 5.099. And I just rounded off over here to variable error equals 5.099. All right, now we're going to calculate what's known as total error or total variability, depending on which author you read. And so we've already done part of the first part of this formula, but in this case, in column D, we're going to take the column C minus column B. So 45 minus 40 equals 5. So if you think back to the constant error, we've already created this set of values, which is the score minus the target value. And in this case, now much like the variable error formula, we're going to take the column D values, which are the difference values, and square them. So in column E, we'll see that 5 times 5 is 25, 0 times 0 is 0, negative 5 times negative 5 equals a positive 25, etc. Then we're going to sum those values, gives us 175. We take the average of 175, or again, divide by n, and that leaves us 35. We take the square root of 35, and that leaves us 5.916, and so our total variability equals 5.916 for rounding. So what you can see is the total error formula is a combination of steps that you've used in the constant error formula and combination of steps that you've used in the variable error formula, and they're combined in such a way that you come up with the value known as total variability. One more little thing we want to talk about. It's kind of a neat feature between constant error, or the relationship between constant error, variable error, and total variability. So based on the formula on page 39 in your main book, you can see that total variability squared is equal to constant error squared plus variable error squared. So E squared equals CE squared plus VE squared. So if you know two of the values, you should be able to calculate the other values. So we know that constant error, which is -3 squared, is 9, and we know that variable error squared, which is 5.099 squared, equals 25.999. If we sum those two together, we get 34.999, which we can see there in column D. If we take the square root of that value, that's 5.916, which actually equals the total variability, which is 5.196. So that should help you understand the relationship between constant error and variable error as it relates to total variability.